Hi everyone, welcome to videos on network topology. This is the network topology part 2 video. In the last video I explained the network topology with respect to the understanding of graph, subgraph, tree, co-tree, oriented graph and incidence matrices. The continuation of the previous video is this video. So in this video I will be explaining the network topology formation of matrices, that is basic cut set incidence matrix, basic loop incidence matrix and branch path incidence matrix. These three matrices formation I will be explaining. To understand the formation of different matrices, we have to consider the network first. Here in this video, as you are seeing, I have considered the oriented graph, the same which was considered in the previous video, the same system it is considered, and let us brief about this oriented graph. Here we have branches which is marked in dark line, that is 1, 2, 3, 4 branches, they are line segments, and the links they are written broken lines, they are 5, 6, 7. So such a oriented graph marked tree and co-tree we have to consider to write the basic cut set incidence matrix. So I will write the basic, it is represented by B. So these three matrix what you are learning today, these three matrix are important. So they keep on asking in the university exams. So first one, let us deal with this basic cut set incidence matrix B. Here the incidence of elements to the basic cut sets of a connected graph is shown in the matrix B. Here this matrix B is having three types of elements, that is 1, minus 1 and 0. So when it is 1, when it is minus 1, when it is 0 is important. As per the procedure, we have to mark the basic cut sets for the oriented graph. When you mark the basic cut set, we have to include maximum of 1, that is only one branch and any number of links. So the order of the B matrix, is element cross number of branches. So that means elements cross branches means we have 7 elements here. So let us write the elements 4, 5, 6, 7 elements, 7 rows, let us mark 4, 5, 6, 7 rows, and see the basic cut sets are equal to the number of branches. Here we have 4 branches, they are 1, 2, 3, 4, they are the line segments. So there let us mark A, B, C, D. So these are the basic cut sets is equal to the number of branches. So how to form the A basic cut set, B cut set, C cut set, D cut set, how to form this? So first, this is first branch, second branch, third branch, fourth branch, let us assume. So first branch means that is connected to the first node. So let us have this. So first node, second node, third node, fourth node. So these 4 buses, Suppose here we have total nodes are equal to 5. If you omit 1, then this becomes buses. So in this example, the buses are equal to the number of branches. So we are forming the basic cut set like this. So the first bus, I will take red color, so that will be more appropriate to mark the basic cut set. See here, this is one basic cut set. When we consider this basic cut set, it is included only one branch and only any number of links. For this basic cut set, we have considered only one element as link. So 1 and 5, these will form the A basic cut set. So here A basic cut set is included only two elements, 1 and 5. So here 1 and fifth element. First element and fifth element are involved in the formation of A basic cut set. So here what we do is, so that is 1. When it will be plus 1 and when it is minus 1. So plus 1 means the element current 1, you see first element, current direction is same as that of the 8th basic cut set, therefore it is 1. Suppose for fifth element, you see current is going out of the 8th basic cut set, therefore it is minus 1. The second element, third element, fourth element, sixth element and seventh element are not involved in the formation of A basic cut set. Similarly, we can write the B basic cut set, that is second node. See here, second node you can mark like this, that is B. So the direction of B, you see here it involves the first element, second element, fifth element, sixth element and seventh element. So here it involves only one branch and any number of links. So let us mark these elements involved in the formation of B cut set. 2, 5, 6, 7. 2, 5, 6, 7 are involved in the Bth basic cut set. So let us see this first element is not involved in 3, 4. First 3, 4 elements are not involved in the formation of B cut set. So directions, let us see. So 2, it's in the same direction as the basic cut set, that is plus 1. 5 is also in the same direction. Away from the second node is 6 and 7. 6 and 7. So you have to mark minus. And let us see the Cth basic cut set, that is C is nothing but this third node. See, this is C. See here, when we are moving the node 3, it involves one branch and one link. So 4 and 6 are involved in this basic cut set formation, 4 and 6. Remaining elements are not linked to the formation of C basic cut set. But 4 and 6 both are into the node, therefore it is follows C's direction, therefore it is plus. Similarly, let us consider the Dth basic cut set. How to remove the fourth node? Here it is very much important is you cannot consider like this. If you consider this as the D basic cut set, but it involves two branches, you should not consider like this. It should have, basic cut set should have only one branch. So what we have to do is, I will consider this like this. This is the D basic cut set. So when I consider this, it involves the elements 3, 6, 7, but it is involving within that 3 and 4, they are merged. So this follows the rule that it has only one branch and any number of links. So 3, 6, 7, 3, 6, 7 branches are involved, or elements are involved in the formation of D basic cut set. And let us see the direction. So 3 towards that node, 6 is also towards the fourth node, 7 is also, they are all plus. So this is how one can find the basic cut set incidence matrix B for a given oriented graph. Yes, we will see the basic loop incidence matrix formation. For that, it is required to have the oriented graph marked with tree and co-tree. In the basic incidence matrix, here the incidence of elements to the basic cut sets of a connected graph is shown in the matrix C. Here also the matrix elements, either it may be 1 or -1 or it may be 0. When it is -1, when it is 1, when it is 0 is the elements of the matrix are 1 when the ith element is incident to and oriented in the same direction of the basic loop. Suppose if the basic loop is oriented away, then it is -1. If the basic loop is not incident to the element, then it is 0. So, let us write the C matrix and then we will analyze the problem. So, here I will write the C matrix. So, C matrix order is equal to the elements cross basic loops. So, the elements are 1, 2, 3, 4, 5, 6, 7. There are 3, 4, 5, 6, 7. And how many basic loops? The number of basic loops are equal to the number of links. Here the links are 3. So, let us have the loop 1, loop 2 and then loop 3. See the oriented graph and we will mark the basic loops. See here we have the links 5, 6, 7. I will take the different color. So, this is fifth element. When I add individually the links to the tree, you will get one basic loop. Suppose if I consider the tree elements as 1, 2, 3, 4 and if I add the fifth link to the tree, you will get one loop. So, let us mark this as a loop and current direction is clockwise direction. So, this basic loop is L1. So, this basic loop is touching only the elements 1, 2, 5. So, here 1, 2, 5. Remaining elements are not touching the basic loop. And see the direction of current of the loop and the current direction in the elements. Second element direction is opposite to that of the basic loop, that is second element is -1. First element direction is same as the loop direction. Next the fifth is also same direction, clockwise, here also clockwise, basic loop also clockwise, fifth element current direction is also clockwise, that is +1. So, like this you can write the elemental values. Similarly, we will consider the sixth link to the tree. If I consider the sixth link to the tree, you will get this loop L2. So, this L2 loop is touching the elements 2, 3, 4, 6, 2, 3, 4, 6. So, the other elements are not linking the loop L2 and we will mark these ones what I written in the table -1 or +1. So, we will see second element is in the same direction, okay, it is going up, this is also going up, second element. Sixth element is also correct, so clockwise, but fourth element current direction is opposite to that of the basic loop L2 direction, therefore, fourth is -1. And third one is also, the third element current direction is opposite to that of the basic loop, third element is also -. So, similarly, let us add one more link to the tree So that is 7th link to the tree, you will get the basic loop. So when you connect one link at a time, you should not consider the previous links which you have considered. So that is, this you should not consider. So that means when we consider the 7th element, you will get the basic loop like this, basic loop. So it involves only the 3 elements, that is 2, 3, 7, 2, 3, 7. The remaining elements are not touching the basic loop L. This basic loop is L3 basic loop. See the current direction. 7th element current direction is clockwise direction. Always the basic loop current direction we consider it as clockwise direction. 7th element current direction is same as that of the L3, and this third element is opposite. Third element is opposite because clockwise direction loop current, and second element is correct. Second element is upward, clockwise is also, loop direction is also upwards. So this is how one can write the basic loop incidence matrix from the given oriented graph. It is easy. Once you practice, it becomes easy. Next, the last element, the matrix is branch path incidence matrix. Branch path incidence matrix. It is denoted by K. So this branch path incidence matrix, it shows the incidence of branches to the paths in the connected graph. So here the path is oriented from the bus to the reference node. So here the path in the subgraph of the connected elements where not more than 2 elements meets at a node. So here we are finding the K matrix. The K matrix order of the matrix is paths and the branches. Branches are nothing but nodes minus 1. So here nodes are 4. Now branches are nothing but nodes minus 1, that is 3. So we have totally in this problem we have totally 5 nodes. So branches are nothing but nodes minus 1, 5 minus 1, that is 4. So 4 branches. Paths are also equal to the branches. So let us consider the matrix 4 cross 4. 1, 2, 3, 4. Here is also consider 1, 2, 3, 4. So the order of the K matrix is equal to the number of branches. Number of branches are 4, therefore it is written 4 cross 4 matrix. 4 cross 4 matrix. How to fill the elements? That is the next challenge. So it is easy. Here we have to see the buses. So this one is reference. So this is the first bus. From bus to the reference, you have to create a path like this. This is the first path from the bus to the 0, that is this one. So it involves only one element, first element, okay, that is only one. So here current directions, assumed direction is downward and the element 1 direction is up. So for this path, path 1, so it involves only one element, second, third and fourth are not included, branches are not included. So next we will consider the path, second path. Second path is from second node to the ground, second node to the ground, second node to the ground. This is path 2, path 2. It involves only second element, remaining branches are not included. So, these are branches. So, here also current direction is minus, because path 2 downwards and second element is upwards. Next, third element, that is third path from third bus. This is the third bus. Path should cover the branches only. Path should cover the branches like this. Path should cover the branches, not the links. So, it is covering 3 and 4. 3 and 4. The first and the second branch is not included in that path formation, and current direction in the branch 3 is opposite to that of the path direction, and the fourth is also opposite. Next, the fourth path from the fourth bus here. This is path 3, this is path 4, path 4. So, that is involves only third element, and current direction is opposite, and the branches 1, 2 and 4 not involved in the formation of the fourth path. So, this is how one can find the K matrix. So, for forming the K matrix, you have to see the title of the K matrix, that is branch path. So, you have to see how many branches, that will be the order of K matrix, and in this example we have 4 branches, and how many paths? Paths are equal to the number of buses. Here number of buses are 4. Now, we have to find the path from bus 1, bus 2, bus 3, bus 4 to the ground. So, bus 1 to ground path is path 1, and similarly bus 2 to the ground, this is path 2, that is this. Next, bus 3 to the ground, that is this path. That means you have to consider only the branches when you are defining the path. Similarly, the fourth bus to the ground, it is marked, and when you are writing the elements in the K matrix, here also it is 1, -1, 0, when it is 1. So, when it is 1, because branch and path, they are oriented in the same direction, it is 1. If the branch direction and the path direction is opposite, then it is -1. Branch and path are not incident, it is 0. So, with this video, you can understand how to form the 3 matrices in network topology. That is, the first one is B matrix, that is basic cut set incidence matrix. Second one is C matrix. Here I am showing you this. The first one is B matrix, that is basic cut set incidence matrix, and then I explained the basic loop incidence matrix, that is C matrix, and then I explained the branch path incidence matrix, that is K matrix. I hope it is useful for you people. Thank you one and all.